Good afternoon, good morning, good evening, depending on where you are on this truly fast forward planet, which is wrapped in layers of turbulence, climatic, political, geopolitical, you name it. We're in the midst of so much change, it's sometimes hard to keep your orientation on a to-do list. And what I try to do with Sustain What is to clarify pathways amid complexity. We're not going to really solve complexity. But we can figure out ways to do that, to get through it and make productive use of our time, our connectivity, especially. And a big focus of mine is communication. And that's why I'm really thrilled to have Dawn Wright on here, who's the chief scientist at Esri, the company. If you don't know, it's kind of like NVIDIA. They're these companies that do really important things that aren't like the IBM, Exxon kind of thing. They don't sit in our heads like Kleenex and the like, but that's because they're part of the landscape of stuff we do. And for GIS, for global information systems and mapping, there's nothing quite like Esri. I've got to know what they're doing when I was working at National Geographic Society, more than I had before. And Dawn is just a spectacular example of a public scientist who she's doing really important research on as an oceanographer. She's a public figure and a role model for young people all over, people of color, particularly because of her background, but for all of us, especially young people. Is it true that there's a Lego character, an actual Lego figure of you?
I'm reaching for it right now. Yes, here's this is a Lego minifig of me and my dog.
I thought so. I
yes,
saw I saw some GIFs of it and stuff, but I wanted to be sure it's an actual real thing. That's a pretty, there's Nobel Prizes and there's, National Academy of Sciences and Engineering, which you're both in, but having a Lego figure is pretty cool.
Well, it is a wonderful thing. And the wonderful thing for me is that someone did make that character several years ago. And so that's what we use in our animations and such. But now Lego has evolved to the place where you can buy the separate parts. You can buy the head, the hair, the body, the legs, the hands, and they come in all different skin colors and hair textures. So you can make your own minifig. Lego does not sell me or sell Victor Vescovo, who is also a minifig that we have made for our film. Victor and I are inside the limiting factor here.
Can you hold that a little bit? Hold that a little closer to the.
So this is from our Lego movie, and that's Victor Vescovo piloting the inside of the limiting factor, and there I am. So
and it's only a little bit smaller than the one you were actually in. No, just kidding.
Yeah, it seems that way. Yeah.
I know. We're going to talk about that, of course. So let me get back to the screen with your book and stuff. Now you have a book out. I have a copy, a physical copy here. That is, it really tells your story of your journey through science and into the ocean, and the story of this particular extraordinary journey to the deepest spot on the planet, the deepest liquid spot. And I just think it's spectacular what you've done. And again, whether it's your social media or just your general being out there aspect of your personality, it's great to have you back on. You, as you will probably remember, we were talking about Maria Tharp and ocean mapping when it was done in a very different way than you do now. So let's start with just sort of a little quick sketch of how you became who you are so far. I mean, I'm not saying read the whole book, but what was there a key moment when you fell in love with the data part of science, for example?
That's a good question about the data part.
When I mean also the visual data part, not just sort of tracking cancer rates or the like.
Well, I think in my case, I fell in love with the the nature that the data are trying to depict. So I fell in love with the ocean as a child, and I think I pivoted to wanting to study the ocean after the Apollo 11 moon landing, which is a little ironic because there were, in 1969, there were so many children who wanted to go into space and become astronauts. And I was 8 years old that year and decided that although that was amazing and wonderful, and I saw these men, these American men doing this, I wanted to go the other direction and explore inner space. Now, I didn't know what any of that meant, and I didn't fall in love with ocean data and maps until the time that I discovered Marie Tharp's work. And in your Sustain What episode, I think that's from 2020, yes, where you have Vicky Farini and I talking about that. We can refer your listeners to that beautiful conversation. But it was in the 1980s when I first saw that 1977 map of the world ocean that Marie Tharp did with Bruce Hazen coming out of Lamont. Right. That was, I think that was a stunning event for many of us, because that map, and I work for a mapping company now, so we at Esri love that map, and we have patterned our Esri Ocean Base Map in a way after that map to kind of continue Marie Tharp's legacy. But the cartography, the art of that piece of work is so beautiful. And that's really what a lot of science is, especially in the map making arena. It's a combination of art with the science.
Right. And here she was at work.
Yes. Yeah.
And what that's about, of course, is the connectivity between scientific data and an audience, whether it's an audience of your peers as an oceanographer or of the wider world, to say, oh, wow, the ocean has topography, the ocean has history, the ocean has shape. I when I was at the New York Times, I wrote the piece about when Google added the oceans to Google Earth. And I interviewed Sylvia Earle, who was kind of shaming them.
Yeah, she
that big blue gap. And so visuals really matter, but it's really a form of communication in the end, really.
Yeah, it is. And I get so tired of seeing world maps where the ocean is just blue. And this was indeed part of what Sylvia Earle was trying to get Google to see. And Google's success with Google Earth was a big impetus for us at Esri to move forward and evolve our mapping systems as well. But when you, now as a geologist, as well as a geographer, oftentimes with the seafloor maps and with Marie Tharp's map, we want all of the water drained off so that we can see that topography more easily. And really, that's what these types of seafloor maps are. They're showing you what the Earth looks like without the water, right, without the water in the way. And so it really is a communication tool that opens people's eyes to the complexity of this planet and the danger of this planet. One of the things that was significant about Victor Vescovo taking me to Challenger Deep is that that's one of the world's largest collision zones,
right,
where two tectonic plates are coming together, and that's the site for a lot of mega earthquakes, for volcanic eruptions. This is why Japan is in peril so much, because they have the Japan Trench right there in their neighborhood, and we were in the deepest part of the Mariana Trench.
Amazing. So we'll go down into that plunge in a minute. There was a question that came in from a viewer, Jeff Suchan or Suchan, says, did Jacques Cousteau influence you? He did me, I'll tell you, growing up in Rhode Island.
He did. He most certainly did. I think he influenced generations of oceanographers. Now, I grew up in the 60s, and so his program, The Undersea World of Jacques Cousteau, was on every Sunday night. So, and as a Hawaiian girl, little girl growing up in Hawaii, I was glued to the TV set every Sunday night to watch that show, along with The Wonderful World of Disney. So yes, there was a big influence.
Yeah, and I was similarly in Rhode Island, same time, same decades. And I had when I had my bar mitzvah, the only present that I remember and that I still have is my U.S. diver's mask. I should keep it's
Oh,
down in the basement. It's
yeah.
one of the ones with like panels on the side and
Uh-huh.
the
Those
glass
are
here and glass
awesome.
there. And I still
Yeah.
use it. I still use it. But it was
Oh,
his
that's
company,
great.
and it was like, how could I not? So here we are. So it's one thing to sit and look at data. It's one thing to even be out on a research vessel. But what prompted you to head down instead of out?
Well, it was the fascination with where I was living, really, and learning in school that Hawaii, the Hawaiian Islands, started on the ocean floor as undersea volcanoes. So it's that whole idea of an undersea volcano. What is not cool about that? Something that erupts, something that is active and is erupting on the ocean floor, and you don't even see it, except if you have a situation like the Tonga earthquake a couple of years ago, where
Yeah.
that event is still being studied, and you could see that eruption from space, and it put flew tons of water vapor into the atmosphere. But the idea that the Hawaiian Islands were formed on the ocean floor under the waves, where you couldn't see, didn't even know about them until the volcanic activity continued to such a degree that the islands got big enough to breach the surface and to be an island. So it's that geologic fact that really got me started in terms of wanting to go to inner space instead of outer space. Now, outer space is still a possibility, I hope. In fact, Victor went to outer space on the Blue Origin New Shepard mission just a
Yeah.
month before he took me to Challenger Deep.
Yeah. And you were the mission specialist. Is
A
that
mission
right?
specialist.
And what was some of the the book lays this out, of course, but maybe you could talk a little bit about the research you were doing down there.
So as you can, thank you for this picture. The prior picture that you have with Victor and I inside the limiting factor is very useful because it does give
Yeah, let me
an
go.
idea of how small a space we were operating in, and it really is like a space capsule. And now a caveat is that we had just one dive, so
Right.
it's like one point in the vast expanse of Challenger Deep and the vaster expanse of the Mariana Trench and the ocean. And we only had 2.5 hours. Oftentimes, with gathering data with a submersible, you need several dives, repeated dives to an area. In fact, my first experience in a submersible, my dive was one dive of a 21 dive series to really figure out the tectonics and the hydrothermal activity in a particular area of the East Pacific Rise. But we were going to Challenger Deep really to test a prototype mapping instrument, and wonderful timing here because the mapping instrument that we were using was developed by Deep Ocean Search of
Hmm.
France and Mauritius. Deep Ocean Search is the same company that supplied the same mapping capability for during the search for the Endurance, Shackleton's Endurance. And that is now a book and a film that is on Disney Plus right now. So you can go to Disney Plus
Oh, wow.
or Hulu, I guess, and you can see that story of that amazing discovery that took place the same year that we went to Challenger Deep. It was earlier in the year. And our mission, and this dive track here lays it out very nicely. Thank you. Our mission was to get to the western pool of Challenger Deep, and that's at the 10,890 meter, that first point there, to do observations of any biota or any geology that we saw, but also to lift up a little higher into the water column to run some surveying lines along the southern wall of the western pool to test the mapping instrument. And this is a mapping instrument. It's called a side scan sonar, and it's often used for locating shipwrecks. So that's why it was used for the in the search for the Endurance, and it was also used to discover the wreck of the Samuel B. Roberts just a month prior, which is now the world's deepest shipwreck. And what you're seeing here is a nice 3D procedural model of the pressure drop and the limiting factor. And thank you for using our scene viewer in ArcGIS.
I did some sifting this morning. It's remarkable.
Yeah, so this you can, if you've got the data, you can recreate and make these visualizations so that other people can understand the data. So the victory for us was that the instrument turned on and gave us live data feeds, because the broader problem with instrumentation or anything that we put in the ocean is that the hydrostatic pressure is so intense. It's so dangerous. We were at 16,000 pounds per square inch at the bottom in Challenger Deep, but oftentimes, and we were at 10,900 plus meters at the deepest extent, but oftentimes systems fail at 6,000 meters because of the hydrostatic pressure. And there had never been an instrument that could function below 6,000 meters to do this type of fine resolution side scan sonar mapping. So Deep Ocean Search was the hero there. They re-engineered their instrument that was used during the Endurance discovery and was also the instrument that discovered the Samuel B. Roberts, which is a World War II, a USS World War II ship that sank in a battle off the coast of the Philippines. Those, I think the Samuel B. Roberts is around 9,000 meters, but to get to full ocean depth, which is to get to Challenger Deep, Challenger Deep's deepest point is 10,935 meters. That was the challenge. And so the instrument worked. Not only did it turn on and function, but it gave us some nice live data feeds. And so mission accomplished from that standpoint.
Absolutely amazing. So you had been in submersibles before and the like, but this was kind of, again, taking it to new depths, literally. Since your there was this tragedy just less than 2 years ago in a novel submarine, and I don't know how much you were thinking about the risk factor here. This one was a particularly well engineered and tested vehicle.
Well, I think yes, the entire scientific oceanographic community was pretty stunned and surprised and saddened by the OceanGate Titan disaster, because the writing had been on the wall for years, really, that they should not have been diving that deep in that type of submersible, a submersible that, first of all, was not certified.
Right.
Every submersible that I've been in has been fully certified. The limiting factor was certified by DNV, which is a Norwegian certification firm. There's the American Bureau of Shipping. There are other organizations that will do a rigorous test of your vehicle. And Stockton Rush, unfortunately, was not willing to do that, to spend the money to do that. And we're hearing more and more now with the U.S. Coast Guard hearings of that tragedy, what was behind the situation there.
That's really.
But I had no thoughts, no misgivings at all. It's one of the things that you do as a scientist, is that you trust the equipment that you're in, you trust the vehicle. I trusted Victor as the pilot. It was Victor's 15th descent to Challenger Deep, so he knows more about that place in the ocean than anyone else.
That's an extraordinary achievement as a human, just to be that passionate about something, and also determined to do it correctly and all the like. Just it's really remarkable.
Yes, and of course, there's a book about there's several books about Victor's 5 Deeps expedition, because that was really the impetus. he wanted to get to the 5 deepest places on the planet, and that launched that expedition around 2018 to 2019. And then his intention was to sell the ship and the submersible and all of the assets and move on to another adventure. And while he was waiting for a buyer, he continued dives. So he pivoted to from record setting, going to the 5 deeps, to returning to places, especially Challenger Deep, and putting someone in that seat next to him, because the limiting factor, which is now called the Bakunawa, by the way, under its new ownership, it's now owned by Inkfish Expeditions, and it is really under the guidance of Professor Alan Jameson and his colleagues at the University of Western Australia. At any rate, it's a 2-person submersible, so he started putting a second person into the seat and taking dives with him, and doing intentional record setting in terms of taking Kathy Sullivan, for instance, down with him to Challenger Deep as the first woman to descend to Challenger Deep. And as we know with Kathy Sullivan and her amazing background, she was the first American woman to walk in space as a NASA astronaut on the Discovery Space Shuttle. And she was the administrator of NOAA.
Right.
And she's done many, many other amazing things. But that dive to Challenger Deep established her as the most vertical person in the universe, having been
I remember.
so high
Yes, I remember where she was posting about that. That's
yeah.
the highs and the lows.
Yes.
That's
And he
incredible.
took Nicole Yamase, the first Pacific Islander, to Challenger Deep. I think a year before I went. She's a marine biologist. He's taken Y.T. Lin, who is an acoustic oceanographer now at Scripps Institution of Oceanography. He descended as the first Asian person, and there are other records. But in addition to the science, these intentional representations of people going to the deepest place on the planet, it's very important, and it is an amazing communication and education and inspiration vehicle that we can use. So hence with my book, and just the broader understanding of the complexity of our planet, as you're showing. It really takes people to go to these places and to explore and to plant the seed, really, to plant the seed for the next explorations. Right. Given the fact that we know so little about the ocean, it's absolutely stunning how little we know. It's crazy.
Yeah, well, that gets to the motivation to do more, and to when you think of what success would look like in a decade or so, there is the Ocean Seabed 2030, which is trying to tell me a little bit about what the goals are here, along with getting people to experience these depths. The goals for mapping and the like.
Yes, Seabed 2030 is a UN Ocean Decade program. There is going on right now the United Nations Decade of Ocean Science for Sustainable Development. And the whole idea there is the push to achieve Sustainable Development Goal 14, which is to understand the ocean and to protect and manage the ocean properly, to pull back the damage that we've done to the ocean, especially through pollution, especially through plastic pollution. So Seabed 2030 is one of the endorsed programs of the UN Ocean Decade. And when Seabed 2030 was launched in 2017, and it's called Seabed 2030 because it's the quest to map 100% of the ocean floor in modern detail, to modern standards. So that's 100-meter resolution or less,
right?
In many areas. In the deepest areas, the standard is around 800-meter resolution, but really we have the capability now and the technology to map everywhere every part of the ocean floor to that high resolution. So when the program was started in 2017, only 6% of the seafloor had been mapped to that standard. But now in the last couple of years, that coverage has risen from 6% to 13% to 20%, because this type of surveying takes time. And here in 2024, the percentage is 26.1%.
Amazing.
So that's the idea. And it does take time, but we are slowly bringing the seafloor into focus because we do have a map, a Marie Tharp type map that was created with satellite altimetry that does show us the ocean floor, but the map is fuzzy. It doesn't. If you focus in on the Mariana Trench, for instance, you're going to need prescription glasses to really see clearly. And the data at that resolution, at that level of detail, is not going to be able to give you. It's not going to be able to bring you into focus. So that's why we have to do this mapping, actually doing it on the ocean and in the ocean using acoustic energy. That's the best energy for giving us the detail that we need. The detail that we need for the ocean that we want.
Right.
The motto of the UN Ocean Decade is the science that we need for the ocean that we want, and Seabed 2030 gives us the detail that we need for the ocean that we want. So this work has been ongoing, and of course there have been leaders. University of New Hampshire, as you're showing here, Vicky Farini's work. Vicky leads one of the regional centers of the Seabed 2030 program there in New York. And we are able to put these data onto one of Esri's globes here, as you're showing.
And this, there are all these issues that are percolating. I did a show, I think it was almost 2 years ago, about seabed mining, the extraction of metals. And as the clean energy or the renewable energy push continues globally, no matter what the new president plans, the demand for that resource is going to be there before the mapping is done. Not only the mapping, but the biological work. So it is an important frontier for many reasons.
It is, and it's exactly right what you say in terms of we do not have the mapping done to sufficient resolution to do environmental impact assessments on these deep sea mining areas. This is the big issue, is getting the UN International Seabed Authority to do right in terms of whether or not they give permission to several state-owned or private companies to prospect in the deep sea. And most of us in the scientific community say that this permission to start mining is coming too soon because the deep sea miners are way ahead of the Seabed 2030 mappers. And what we're trying to prevent is the accelerating potential for a brutal scavenging. It's really what it is, a scavenging of the wealth that we know is in the ocean's deepest areas. But there are also all of these beautiful, wonderful, useful species that we're still discovering. These areas are habitats. There's also, and Victor Vescovo has talked about this from a very interesting aspect also, because he thinks that it's not only is it not environmentally sustainable, but the basic economic assumptions of deep sea mining right now do not work. There is the technology, as we've shown with our dive and with our mapping instrument. A lot of this mining technology will break and not function at 4,000 to 6,000 meters. The metals company, their own financial document says that they will produce less than 3% of the world's nickel production working 24/7. But in the meantime, that's going to destroy tens of kilometers of seafloor and habitats. So right now it's not even financially viable. And we are working, you're not going to find lithium on the seafloor in these areas. That's the mineral that we all think of because of lithium batteries, but seabed mining is not the way to get that particular mineral. There are all kinds of issues, and we could go on and on.
Yeah, yeah. But they all speak to the importance of having more data.
Yes, definitely.
Promptly.
Mm-hmm.
Is auto? Here's just a sort of a Google image grab bag of what's going on, and the prototyping and the resource there. I remember Bill Broad at the New York Times when I was there. Bill Broad was writing about this stuff 35 years ago at the Times, and now as the demand has risen, it's really heating up.
Mm-hmm.
But these issues are really important. It's a global.
Yeah.
This is the global ocean. This is what Ian Urbina, the journalist, calls the outlaw ocean. It's extra outside of national, international. I mean, outside of national economic zones. It's kind of.
Yes, it's the high seas.
Yeah.
So it's often called the Wild West as well. And so the High Seas Treaty that was just enacted and is in the process of being ratified is another important tool here.
Right.
Smaller nations such as Palau have actually ratified the High Seas Treaty. And the hope is that the United States will at some point do so. But it is the idea of getting the exploration and the data collection and the understanding of these areas that has to happen first before we move to these other activities to exploit the ocean. And the whole idea is any exploitation has to be sustainable.
Right. Boy, it's a tough go. We still haven't signed on to the ocean, the big ocean, to the original ocean treaty. And
the law of the sea. Yeah, we have not signed on to that. Yeah.
And I remember actually the people at the University of New Hampshire, this takes me back a dozen years at least. There's a scientist there, Larry. Come on, brain. There's someone there he was mapping the Arctic Ocean, and
that's Larry Mayer. Yes.
Yeah. I did several stories on that where, the geopolitical importance of having accurate maps of the ocean bed is key because of these features in the ocean floor can determine who quote unquote owns it if it's within national territory and the like.
Yes, this goes back to two maps and what maps show and how the majority of maps are just showing us the surface, and these boundaries that are lines on maps that we see, such as the exclusive economic zone. Those lines extend in 3 dimensions to the seabed. So the boundaries are. We tend to think of things in the scientific community now as volumes. These are volumes of water that we own or that we manage or hopefully protect. Right. And the boundaries extend below the sea surface. So you are just seeing only part of the picture there. And this is why these types of globes, such as you showed before, the visualizations that show us what the ocean is like below the surface are so impactful and so revealing of what we're dealing with here.
Yeah, I'm showing just one quick view of one of these mapping in support of law of the sea. This is the Alaska Eskimo Whaling Commission. This relates to indigenous communities in some of these cases too. One of the neatest things I saw in ocean governance discussions was maybe starting around 8-10 years ago, when the small island states that I grew up with writing about climate change,
yes,
are now big ocean states.
Yes, they are.
Such massive ocean sovereignty. It's just so interesting.
It is. And my Esri colleagues and I were at the Small Island Developing States Conference, the 4th one in Antigua, and they were talking about being big ocean states and also about the blue continent, especially for the Western Pacific SIDS or bosses.
Mm-hmm. Well, I wanted to take this conversation back onto land. You're chief scientist at Esri, and there's a lot going on, especially for me. You know, I write so much about risk, disaster risk, uh, risks of flooding, so many hazards, where mapping and sort of starting to figure out how to take in multiple dimensions of data, like different kinds of data, to
Hmm.
help communities uh, plan to understand their exposure and their vulnerability better, and to plan for hazard, which is a
Exactly.
very
Hmm.
different way of thinking than most people do. And I just want to show one resource that gives us sort of a view of how Esri works with communities. I was pretty impressed with this. If I can get the right screen here. Hold on one second. Oh, I know what I can do here. So this is from one of the Esri websites. I posted on my blog
Hmm.
this morning about this. So here you have, you know, the community, and this just shows some examples of how you work both with ecosystems and human systems
Hmm.
to pull data
Yeah.
sets together. So can you just talk through what Esri can mean for someone in Dubuque? I'll show the Dubuque example in a minute.
Well, what you're showing here are a variety of the different ways of communication that we provide.
Mm-hmm.
This is a web map where you can swipe between two different scenarios and
Right.
see what will happen in your area over time. This is showing ArcGIS Urban, which is essentially giving you a digital twin of an area. This is a story map where you can take all kinds of data from different sources and from different in different formats, and you can put them together in a single narrative. So if you're talking about environmental risk, or if you're talking about fighting wildfires, and you're trying to relay what the issues are for that particular topic and what we are actually seeing in terms of how that particular topic is affecting people's lives. And wildfire is a huge one right now, especially with climate change.
That's for sure.
And the causes for wildfire, the, uh, the, the, the implications of wildfire for people's health, not only for losing landscape and losing your buildings, but what's going on with the air quality, how many species are being wiped out, what are the implications for what's the risk of rebuilding in these areas.
Right.
And oftentimes, Esri technology, we are known for our maps, but really, what the best part of what we make is the analytics uh, that
Right.
you can do on the data to give you the map, and also to give you maps that tell you what's going on right now, but also what the implications are in the future. So predictive maps, or maps that help you design. So this is a very nice example that you're showing here in terms of how we can do landscape design to improve communities, so that when the next flood comes, because that's one thing that we're realizing, these are not just one-time events. With the way
That's
that the planet is heating up and changing, there is going to be another flood. There is going to be another hurricane. There is going to be another wildfire. And in between those events, what changes can you make in your community? Uh, where can you put buttressing or protections along your waterways? How far back should you move the new buildings that you plan to construct in these areas in order to keep things safer? So
right.
this is often referred to as geo design, designing for the future, using landscape and socioeconomic factors, and of course doing this in a mapping environment.
It's so important. And under, you know, I talk about this sometimes. I was at Columbia University for 4 years, and I learned that something like 30 years ago they closed their geography department. Eh,
Yeah.
and it just blew my mind. That's why I like Esri's. This is one of Esri's mantras. That geography is at the heart of a more resilient and sustainable future. And part of this for me, I'm just scrolling through my own story that I did today with some of your input. It isn't just information about like future changes and the hazard, which is related to global warming. It's like, how much do you understand about the history of hazard in your neighborhood?
Hmm.
And
Yes.
in Western North Carolina is this classic example where, as when I was writing about it, um, I quickly stumbled onto some Tennessee Valley Authority study from 1960. That was this huge analysis of flood history. There was epic flooding there in 1916 and in 1791. And I've come up with these graphics. These are some of my little education projects. Mind the Gap. I have a series of Mind
Uh-huh.
the Mega Flood Gap. This was Asheville. Here's 17. This is 2024. This is 1916.
Mm,
And the only reason this is worse is because the river had been constricted in the meantime. People had
mm.
built stuff between 1916 and now that made the river able to rise higher. And here's 1791. So, and that was
Wow.
an April storm. So it was very unlikely it was a hurricane, but something epic happened there in April 1791 that we
Yeah.
still don't understand. So communities, if you're not attuned both to the historic data
Hmm.
and your own trends and your zoning, so what does our zoning need to change, or our fire codes alike, and then the future, which is the climate change, changes in storms and like, then you're building what these wonderful geographers whose work I also refer to all the time call the expanding bullseye. We're just building bullseyes, and the hazards. This
Yes. Hmm.
hazards are the darts, and this is just the most basic view of a bullseye. This is rural, exurban, suburban, urban,
Mm-hmm.
and that's the path of
Yeah.
a tornado.
Hmm.
And this is Steve Strader and Walker Ashley. And as the community grows, and it goes to 2040. So they're
Yeah.
saying you're building in a zone where this kind of tornado is
You've
a
put a target
feature.
on your back. Yeah.
Yeah, you're building a bigger bullseye.
Yeah.
So geography matters hugely, and I think even as journalists, we tend to hyper focus on climate science. Is really cool, right? I started writing about it in
Hmm. Hmm.
1985, but I needed to talk to more geographers, and then the social scientists, of course, who understand why people build where they build, and like. So what's really cool about your work is you're kind of at the interfaces of those disciplines, and people can use the tools at Esri to kind of bring in those different dynamics, which I think is really cool.
Oh, absolutely. And we make tools with these various disciplines in mind. The wonderful thing about geography is that it straddles the physical and the social sciences, and you find geographers in other departments. So at Columbia University, there are geographers everywhere, even without a formal geography department.
Right.
So they are in urban planning, and they are in architecture, and they are in the geosciences. Now, of course, geography as a discipline really focuses that energy and that expertise. And if you do have a geography department, that is the best of all worlds. But one of my roles as a chief scientist is to bring these scientists into collaboration with us, so that as we are building the next version or the next revision of our tools, we have the needs of urban planners and of architects and of wildfire scientists in mind, and we will build in functions that they need, or give them the ability to create their own functions. We do a lot of open source within the Esri ecosystem, so we bring that in as well. And it really is an ecosystem of tools and capabilities to optimize how people are using our technology. So that is part of the beauty of it.
That was, yeah. I remember I was at some brainstorming session years and years and years and years ago on how to facilitate conservation and protection for indigenous communities in rainforests. And the tendency is to say, "Oh, let's just come down there with our gadget." But what was discussed at this meeting was the importance of just what you were saying, the conversation with indigenous communities, because they might have a totally different sense of what they need, or how to use that sound detector that might, map an outboard motor coming up their river that was not legal. And
Yes.
so you have to have those conversations.
We have one of our collaborations right now is with the Woodwell Climate Research Center up in Woods Hole. And they are doing quite a bit of work with Alaskan Native communities around the issue of permafrost thawing.
Yeah, sure.
And how those communities, they need to migrate, they need to move entire villages to move away from these very, very difficult areas. And how do you do that? Thank you. So Greg Fisk was one of my students at Oregon State University. He took his first GIS class with me, and boy, has he gone a long way. But they are working with those communities to help them tell their stories through our modern mapping technology, but also they are using the modern mapping technology in ways that the technology needs to change in order to accommodate their wisdom and their indigenous science. I very strongly believe that indigenous science is very, very rigorous science that we've ignored for far too long. And so the Woodwell team is doing some beautiful work there. And they are funded by the Audacious Prize, which is another neat thing, which is the next generation of the TED Prize. The TED Prize turned into the Audacious Prize. Huh. So that's helping them to fund their efforts.
Let me see. There's a couple more questions here, I think, getting back to the book and your oceanic adventures. Oh, yeah. Jeff is asking, so how long could you stay down safely? And
a safe dive all the way to Challenger Deep, as deep as you can go, is around 10 hours. It takes 4 hours to slowly and safely descend. And for our particular mission, we had 2.5 hours on the bottom to do our surveying. And then it was about 3.5 hours to ascend. And that's very carefully done because of the battery power. And we have to make sure that we don't run out of battery power. So there have been a couple of dives to Challenger Deep. I think the one that Kelly Walsh did, I'll have to check on that. But Kelly Walsh is the son of Don Walsh, who was the first man to Challenger Deep along with Jacques Picard in 1960. And Victor took Kelly down to Challenger Deep to the eastern pool where his dad first descended. And I think that was a fairly long dive, a little over 10 hours. There have been a couple of dives that have been a little longer than ours, but they're usually around that length of time.
It's amazing. What's your hope for and/or concerns related to the next coming generations of Dawn Wrights and Sylvia Earles and the rest? What do we need to be doing that we aren't doing, if anything, to try to spur, other than getting your book around and what is there when you look around classrooms or this country right now? Is there untapped possibilities we haven't thought of yet?
I think it's just a very simple problem of getting our story out to enough people. Now, I didn't grow up in the Black community. I grew up as a Hawaiian girl, and our Black family was the only family on Maui. So I grew up more in the Polynesian and the Asian culture. And I've been so surprised by so many of my friends and colleagues from Black communities throughout the southeastern U.S., for instance, where swimming or getting into the water, getting your hair wet,
Right.
is something that is not thought of as something that Black people do. It's amazing to me how pervasive that is still in our culture, and getting the word out to the Black community. There's a fantastic organization called Black and Marine Science that is doing the same thing on a much broader scale, because they have opportunities for young people to not only get into the water, but to get certified as scuba divers and to understand the whole range of marine science, and how you can get into marine science, and how it is for us. It is for everybody. This is an amazing opportunity for young people. Something as simple as this. Here we go. Yeah, helping people worldwide learn how to swim.
Well, you know, it was funny. That came up for me when it was the conference. I think you were there a couple of years ago on ocean futures. And I was looking on the UN websites, and there was a UN push for the World Drowning Prevention Day. And then there was Ocean Action. And I thought we should put them together.
Yeah.
So that you're fostering the capacity to swim, but also sometimes with a mask. So
yes,
when there was a time with my students when I was at Pace University, we did a film about coral reef conservation in Curacao in the Caribbean. And a local official told us how rare it was for Curaçaoans to put their head under the water. They fish and catch the fish, but they're not really experiencing what's down there. And that really got me focused on what can we do to sort of do both at once. I think I've got an image. Oh yeah, right here. This was a swimming class. This is from our movie, the film we did over here in Curacao, and just getting kids in the water, not just experiencing on a screen if they have one, is a real part of the future. The picture on the left is my dad, dear departed dad, who grew up in Rhode Island, you know, loving the water. And of course I did too. And so having that experience can then transition through generations. It just feels to me so important.
You hit the nail on the head. And so there's something as simple as that to something as complex as what may happen in Curacao in the future, because going back to Jacques Cousteau, Fabian, his first grandson, has put together this company called Proteus, and part of what Proteus is trying to do is to establish the equivalent of the International Space Station underwater.
Oh, right. I've heard about this.
To do similar experiments. And Curacao is, I think, one of the sites that they're considering. I had the wonderful opportunity to be with Lisa Marachino, who is the CEO of Proteus. She and I were part of a State Department delegation to Cabo Verde off the coast of Senegal. That may be another site. I met several wonderful kids in Cabo Verde who were in the ocean every day and loving to swim. And there's an amazing nonprofit of many that are in Cabo Verde, where they go out with artisanal fishing vessels, rowboats, and that's how they collect their data for sea turtle and shark and seabird conservation. But that particular fishing village where they are based, there are kids in the water all the time, and understanding how beautiful and how they have fallen in love with it. Part of what so many of us are trying to do is to get people to fall in love with the ocean. And you can fall in love with the ocean regardless of where you live. But falling in love with the ocean is the first step toward protecting it, using it properly. And this, I noticed that you had Ayana Johnson mentioned there. I mean, the work that she is doing in terms of like her new book, What If We Get It Right?
Right.
This is a life and death activity. This is a life and death struggle that we have now in terms of getting humanity turned toward doing the right thing by our planet that is 71% ocean.
Yeah.
Our planet in which we've only seen 0.001% of the ocean. That's a figure by Katie Croft Bell and her colleagues at the Ocean Discovery League. We have only seen, like with the mascot you're talking about, 0.001% of the ocean. Amazing. Let alone trying to map the bottom of it to 100%.
Well, I'm going to show, just to cap things off, you're reminding me, I was a speaker on a Lindblad National Geographic journey to the Solomon Islands early this year. And for the first time, I experienced water music as the Vanuatuans do it. And it's women who do it. And let me just show this. Thanks so much for being here today. I hadn't even thought about this until now. We all need to do this.
Yeah.
They turn the ocean into a percussion instrument.
Yes, into an instrument. It's amazing.
Maybe we should spread this practice.
Oh, thank you.
And you can see the kids. The kids are learning it as their mothers and aunts are doing it. So
that is beautiful. Thank you for showing that. That's going to be with me all week.
I'll send you the post I did about it. Now I am thinking it wouldn't be hard actually, there's been research. A physicist did a paper about how they generate these different sounds. So there's several layers of science there. So thanks again, Dawn Wright, for being a guest on the show today. I'm going to spread this widely. It goes out on my, my newsletter. Anyone can share the link when we're done that they've been watching on, and let's revisit some of these issues sometime. I'm really focused on helping communities map for resilience going forward. So that's something I really care about a lot, and I've done shows on before, and whether it's wildfire or flooding or the like, that's really important to me, along with the key, the ocean frontiers. Thanks again, Dawn Wright, Deep Sea Dawn, on social media.
And there are also a lot of these resources for mapping and data that you can actually get with the book, with the Mapping the Deep book. Mappingthedeep.com has tutorials and workflows, online software. There's even the Lego movie. That's all at mappingthedeep.com.
That's great. I'm putting that right there. And thanks again. Great to see you.
Thank you.
Stay well, stay wet once in a while.
All right.
All right. Take care. I'm going to hit the end.